Hi there, we're going to do some factorising. Now, we've done factorising recently, I believe, or if not, ignore this, but of quadratics where we're doing double brackets. This is the sort of single bracket version of it. But the first thing I want you to do is find the highest common factor of these pairs of numbers, which is what HCF stands for. So you look for factors of each number, so of 20 and 21, and you find the ones that are common to both, so what is a factor of 21 and 14, and you want the highest one. So what's the biggest number that divides 21 and 14? Okay, right, off you go. Pause the video, unpause when you've done them all. Okay, so if we were doing this the long way round, if I wasn't sure of all the factors, I'd probably do some factor pairs. So I'd do factor pairs of 21. So 1 times 21 is 21. 3 times 7 is 21. And those are the factor pairs for 21. So all four of those numbers are factors of 21. Then I do the same for 14 as well. So 1 times 14 makes 14. And 2 times 7 makes 14. So all four of those are, factors of 14, all four of them. Now I want the one that's common to both, so that would be either 1 or 7, but I want the highest one. We're always after the highest common factor. So the highest common factor of these is 7. Okay, and in fact for the next one it is 5, and then 8. It's not 2 or 4 because 8 divides 8 and it divides 16. So the highest common factor is 8. It would be 10 for this one. And then 15. 5 is a common factor, but 15 divides both of these as well. Then 14, again, 7 would divide both, but 14 is bigger and also divides both of them. And lastly, 8. So the thing is, don't forget that one of the numbers itself could actually be a factor, a common factor, possibly the highest common factor. Okay, right, move on. Fully factorize these expressions. Right, what does it mean? Well, firstly, it's the opposite of expanding. Now, if I was to expand this bracket, I would do 4 times 2x to get 8x, and I would do 4 times the 3 to get 12. So it'll be 8x plus 12, okay? Now, what we're going to do is go the other way. We're going to factorize. That means I need to find things that are common to both that I can sort of divide out of each one and put at the front of the bracket. It's the opposite of expanding. On the expanding, we actually we multiply each one by a number. This time we're going to divide each one. And it's not just numbers that come out, although that's where we're going to start. So, looking at this, what would I need to take out of these two to put at the front? Well, it's going to be the highest common factor. That's the first thing you should do with these, is find that highest common factor of the two numbers, or three numbers or whatever. Okay, now the biggest number that divides both is 4. So I'm going to put 4 at the front. Now, they don't share anything else. At this point, if they shared some letters, I'd start thinking about that, but they don't. The only thing they share is the fact that they're both numbers in each. And when I say both, right, I mean both things. So I've got this thing here, this 8x, and I've got the positive 12 over there. So I'm trying to find something that divides both. Okay, now I'm going to try and make 8x, but starting with whatever is outside the bracket, so 4. Well, I need to times it by 2 to get the 8, and then I need to also have the x, right? So that would be 4 lots of 2x would make 8x. Then I need to make that, so that's complete now, I've made 8x. Now I need to make this positive 12, and I would need to times it by a positive 3 to get 12. 4 times 3 is 12. Now we knew that because that was the example I used over here. But that's what I'm doing. Find the highest common factor first, highest common factor, put that outside the bracket, then see if they share some letters, but we're not going to do that for now. For now, we're just going to concentrate on that number. Once we've got that number outside the bracket, what do you need to multiply it by to make your original expression? So let's do it again. What's the highest common factor of 6 and 30? Well, it is actually 6. 6 is the biggest number that divides both. They don't share anything else, so I open my bracket. Now, I need to make 6y. I've got 6, so I need to times it by y to make 6y. Okay, so 6y is fine. Now I need to start with 6 and make 30. Well, how many 6's in 30? There are 5, so I would need to times it by 5. So again, if I expanded this, I get 6y plus 30. It's exactly what I want. It's just my original expression, just with the factor taken out and put outside the bracket. 15x minus 5. Okay, again, highest common factor, that's where we're starting. The biggest number that divides both is 5. Okay, well, I now need to open up my bracket because they don't share anything else. And I need to make 15x. So my 5, I'm going to times it by 3 to make 15. But we need the x as well, so it's 3x here. Okay. If you ever need to check it, just like work backwards, a little mental check. You know, if I expanded this, would I get 15x? Well, 5 lots of 3x is 15x. Yes, I would. Good. Okay. Now I need to make minus 5, starting with 5. Well, I've got to times it by something. You know, it's got to be 5 times something to make that negative 5. Well, let's times it by negative 1. Okay, if I do 5 times 1, I get the 5, don't I? And in this case, it's 5 times minus 1 to get minus 5. So make sure, just because I've already got 5, doesn't mean it's got to disappear. I must have something in that bracket, and it's usually a 1. Okay, right, biggest number that divides 14 and 21. That would be 7. Okay, they don't share anything else, no other letters shared, so open up my bracket. I need to make 14, starting with 7. So what do I times it by? I times my 7 by 2 to make 14. Then I need to make 21y. So 7 times 3 would make 21. And that's negative, isn't it? So 7 times minus 3 is minus 21. But then I need my y as well. There's no y here yet. None of them anywhere, you know, so I need to put the y in. Again, if I expanded it, just a quick check, would I equal this? Yes, it would. Good. Okay. Right, there's a few for you to practice. Just find that highest common factor, put it outside the bracket, and then write down what you need inside the bracket to make it equal the original expression. Okay, nothing can disappear. Off you go. Now pause and unpause when you're done. Okay, we've done the questions. I've had a slurp of coffee. That's cool. So highest common factor of 2 and 14 is 2. So open up the bracket. Now I need 2e, so I times it by e. The dog is eating a trainer he shouldn't be eating, so let's rescue that trainer. Okay, done. Working at home with the dog is tricky. Okay, now I need to make 14 starting with the 2, so you need to times by 7. Sorry, that was someone moaning about the dog eating a trainer. Fine. 2 times e makes 2e, 2 times 7 makes 14. Cool. Next, what divides 7 and 21? That would be 7 itself. Now I need to make 7y, so that 7 needs to be times by y. And I then need to make 21. So 7 times 3 makes 21. Again, just think, if you're not sure, expand the bracket. Would I get this? Yes, I would. Right, 5x minus 5. 5 is the biggest thing that divides both of those, unsurprisingly. I need to make 5x, so I times it by an x. I need to make minus 5. Now remember before we said we times it by, if I times it by 1, I'll get the 5, that's fine. But I need minus 5, so I times it by minus 1. Okay. Right, 14 and 21. What's the biggest number that divides both? It is 7. So open up the bracket. I need to make 14p, so I times it by 2 to make 14. And I need a p. Not really. Oh, I don't know why that makes me laugh. That's so juvenile. 7 times 2p is 14p. 7 times 21 is... Oh, sorry, 7 times 21. 7 times 3 would make 21, which is why that's got to be 3. Okay, next one. Let's go a bit faster now. We've been doing a few of these. Oh, I did A, C, E, and G, didn't I? Well, that's a bit weird. Okay, so 8 would divide both, and I need a p and a -2 inside my bracket to make that work. Okay? Next one, 12. Now, if you didn't put 12, you've not fully factorized it. You need to find that highest common factor. Well, 12g. 12 times g makes 12g, yeah. And then I need to times the 12 by -3 to make -36. So times it by 3 to make 36, and it needs to be negative. Biggest number that divides these. Now 3 divides both, but 9 is the highest common factor. I times it by b. And how many 9s in 18? Well, that's 2, so I need to times it by 2. Yep. 9 times b and 9 times 2. And the last one of these, highest common factor, 3. Okay, now I need to make 9d here, starting with 3. So I times it by 3 to make 9. And then I have the d, so that 3 times that makes 9d. And then I need to make 12 starting with 3, so I times it by 4. So 3 brackets, 3d plus 4. Okay, I did answer them in slightly weird order, but they're there now. Good. Move on. What about these ones then? So this time, if I was expanding this, look what happens when I do my 4x times my 2x. Well, my 4 times 2 makes 8, but x times x makes x squared. It's like the two of them have come together, and for neatness, we just put the power of 2. And 4x times 3 would be 12x, basically 3 lots of 4x. Right. So if I was factorizing this and I didn't have the fact that I've already sort of done the expanded version, so I know where I need to get to, I would still start in the same place. I would still start with the highest common factor. So always find that HCF, really important. Now the highest common factor of these two is 4, but they do share some letters here. Right, this one's got x squared, so that's like 2x's. Think of it as 2x's in a way. And this one has got x. Now x is really just x to the power of 1, so it's got one of them. Now you take, if they've both got an x, you take the smallest number that they've both got and put it on the outside. Right, so this one's got x to the power of 2, but this has only got x to the power of 1. Now that means they've both got at least 1. At least 1, so we put that x on the outside. I can't put x squared on the outside because this one doesn't have x squared, it just has x to the power of 1, just one of them. And then I open the bracket. Okay, I need to make 8x squared is what I need to make, and I've got 4x. So do the number first, times it by 2 to make 8, and then think, what do I need to times it by to make x squared? Well, that would be an x. Okay, so that makes 8x squared, because now it's x times x, right? Now we need to make 12x, or 12x to the power of 1, okay, so just the 12x. Now let's do the number first, so 4 needs to be times by 3 to make 12. I need an x, and I've got an x. I've actually already got my 3 lots of 4x to make 12x. Okay, hope that helps. Let's try again. Again, same thing every time. Start with the highest common factor first. Biggest number that divides 6 and 30 is 6. And then look, they've both got a's. Now this got just one of them, hasn't it? A to the power of 1. This got a to the power of 2. So they've both got at least that one a. So it goes outside the bracket. And then open up the bracket and fill it in. I need 6a. And I've got 6a. But the problem is, if I don't have something here, if I don't have some kind of placeholder in a way, then my 6x won't have anything to multiply against to exist. It will just disappear into nothing. Right? So I need a 1. So there's always going to be something. You know, if I've got 2 things here, there need to be 2 things in my bracket. Then it's going to be 1 here for the first bit, because 6a times 1 is 6a. Right? So if you've taken all of one kind of term, one element outside the bracket, you replace it with a 1. Okay, 30a squared. Now I've got 6a, so I'm going to times it by 5 to make 30. 5 times 6 is 30. And I need a squared, and I've only got one of them. I've only got a essentially to the power of 1, isn't it? I've just got the 1a. So I need to times it by another a to make the a squared. So 6a brackets 1 plus 5a. Don't worry, it sinks in. Once you've done enough of these, it just sinks in and you get the whole rhythm quite quickly. Right, highest common factor of these is 5, isn't it? 5 divides 15 and it divides 5. Then look at the letters. Do they share any letters? Yes, they do. Look, there's an x there and an x here. So 1 there, 1 there. That means they've both got an x. Both terms have an x, so it can go outside. Now this one's got a y this term, but this one doesn't. So don't share it. So that's it. We're done with stuff they share. Now we need to make 15xy, starting with 5x. So times it by 3 to make the 15. Then I need an x. Well, I've got an x. That's great. I need a y. I don't have a y yet, so we need that. And think, what would happen if I expand this? I'd have 15xy, because x times y. Make sure that no elements disappear. Now, I've got 5x, but I need negative 5x. So I need one of this, but it needs to be negative. So I times it by negative 1. 5 lots of minus 1 is minus 5x. Okay, 14x cubed y, take away 21xy squared. So this looks much harder, but it's still the same principle. Start with the highest common factor. Yes, Murphy, I shall let you out in a second. 14 and 21. Highest common factor is 7. Then I've got x cubed, and this x, it's only 1x here, isn't it? X to the power of 1. That means they only share 1x. I know this has got x cubed, but the bits they share, there's only one of them. Now let's let the dog out before he gets too excited. Murphy, off you go. He's obviously given up. Murph, where you gone? Anyway. Okay, so I've got x there. Then, do they share anything else? Yes, they've both got y's, haven't they? This one's got y to the power of 1. This one's got y squared. Now, I know this one's got it squared, but this one's only got 1. That means they both have at least 1. You can only put stuff outside that they've both got. Okay, I can't put y squared because this one's only got 1 of them, not 2. Then open up your bracket. And let's make 14x cubed y. Still got 7, but I need 14. So I times it by 2, because 2 7s are 14. I then need x cubed, and I've got 1 of them already. So if I need 3 of them, how many more do I need? I need 2 more. And then a y. I've already got a y, and I need a y, so that's done. That's happy days. Okay, there's negative here, so let's put the minus in. I need to make 21, so we will times the 7 by 3, because 3 lots of 7 is 21. I then need an x, just the one of them, and I've got that, so that's good. I then need y squared, so I need like 2 y's. I've already got 1 outside the bracket, so I just put the other one there. 7 times 3 is 21. X doesn't times by anything, so it stays as x. And y times y makes y squared. So happy days. Right, your turn. 3 of them for you to have a go at. Pause the video again. I urge you to not just skip this bit, but really have a go. Just look back on what I've done, re-listen if you need to, and do those 3, please. Okay, unpaused. Highest common factor, 5. They've both got a b. This is b to the power of 1, this is b to the power of 3, so they share 1 of them. So that 1 can go on the outside. Okay, now I need to make 10, so we'll times the 5 by 2. And I need a b, and I've got a b, so happy days. Now I need 25, starting with 5, so I times it by 5 to make 25. Now I need b cubed, I need 3 of them. I've already got 1, so I need 2 more to get it up to b cubed. Yeah, because the b times the b squared would make b cubed. Highest common factor, 12. Yeah, it's not 6 or 4, it's 12, because 12 divides both of these. This one's got an x, but this one doesn't. This one's got a y. It's just one of them. This one's got 2 y's. So they've both got a y, so that can go outside the bracket. It's a factor. Okay, I need 12xy. I've got 12. And I've got y, but I don't have my x, so I shall put the x in, times it by the x. 24, I need to times the 12 by 2 to make 24. I've got a y, but I need y squared. I need 2 of them, so I need one more y. So put a y. 12y brackets x minus 2y. Okay, this one looks a bit nasty, but it's okay really. Remember, when it's just a letter on its own, it means it's to the power of 1, just one of them. Biggest number that divides 14 and 21 is 7. X cubed, but just x to the power of 1. So they share at least 1. So we'll put x. We've got y to the power of 1 and y squared. That means that they share at least one y. Well, only one. This one's got 1, so we put 1. Open up the bracket. I need 14, so I times the 7 by 2 to make 14. I need x cubed. That's 3 of them. I've only got 1 so far, so I need 2 more, so x squared. Then I need a y, and I've got a y, so that's fine. Minus 21. Okay, well, we need to times the 7 by 3 to get up to 21. I need an x, just the one x, and I've already got the one x. I need y squared. Oh, that means I need one more y, because I've only got 1 here, and I need 2. So times it by another y. Right. Good. I hope you got those right. If not, just have another listen to it again. As long as you follow it, that's the main thing. Okay, now I'm going to go through the answers to these a bit quicker when we get to them. I want you to just absolutely nail these before we move on to the next bit. Okay, so 8 more for you to do. Off you go. Pause the video, unpause when you're done. Okay, cool. Let's go. Right, what do they share? What's the highest common factor? Ah. Well, now we've got a problem, haven't we? What's the biggest number that divides this? Well, it might help you to think of this as 1, which means the highest common factor of 1 and 7 is just 1. I can't take a number outside, really. I could write a 1, but that's not really going to make any difference. So I'm going to move on to the letters. Now I've got y squared, and this has got y to the power of 1. So they've got at least one y between them, so that goes on the outside of the bracket. Okay, now don't share anything else, so I open up the bracket. Now I need to make y squared, just one y squared, okay? So I've got y, I'm going to times it by another y to make y squared. I then need to do plus 7y. Okay, so I need 7. I need to times it by 7. And 7 times y makes 7y, okay? Tricky one, that one, really. Even though there's not much to the actual expression, you have to really sort of dig deep and think about that one. Right, 12 and 16. Highest common factor is 4. They've both got p's. That one's got 1, that one's got 2. So we'll put that one on the outside. Right, 3 times 4 will make 12. I need a p. I've already got one. I must stop using the letter p, which makes me laugh. That already makes 12p. If I expanded that, multiplied them together, I'd have 12p. So all done. Next part, 16. So I times the 4 by another 4 to make 16. And I need p squared. That means 2 of them. I've got 1 so far. So I put another one. Again, if you're never sure, just mentally expand this out and check that you get the original expression there. Okay, right, I've just got a cat situation and a dog situation, so I'm just going to sort that out. Hold on. Okay, disaster averted, all sorted. Next, right, 3ab minus 9a. Okay, we've got 3 and 9. Highest common factor is 3. Okay, then we've both got an a, so that can go outside. This one's got a b, but this side doesn't. All right, so open up the bracket. I need to make 3ab. Now I've got 3a, I just haven't got b. Then I need minus 9a. Well, if I times it by the minus 3, 3 times 3 makes the 9. And I need an a, and I've got an a, so happy days. And you don't want any more, because otherwise when you expand it, you'd have more a's than you need. Over here, again, no number that they both share. Oh, dogs, cats. Ah, dear. Anyway, right, yeah, they both would need a number there to be able to put a number on the outside. So we'll look at letters next. This got a B, but this one doesn't, so they don't share that. But this one has a C, C to the power of 1. This one's got C to the power of 2. So they both have a C. Let's put that on the outside of the bracket. Okay, right, I need to make BC. I've got a C, just need a B. Oh goodness, hold on. Murphy, the cat has gone outside because he doesn't like you. Right? Done. Now shush about it. Right. Then, sorry about that interruption. Plus 2c squared. Now I've got a c. I need to times it by 2 to make 2c. But I need c squared. I need 2 of them, don't I? So I need another c. And just imagine, c times this would make 2c squared, because c times c. Right? 8 and 20. Highest common factor is 4. This one's got an x, this one's got an x. Excellent. So they've both got an x, so we can put that on the outside. This has got a y, but this one doesn't. So we'll open up our bracket. 4x is the highest common factor. Right, I need to times it by 2 to make 8. I've got an x already, but I need the y. So when I multiply this, I get 8xy. 8xy. Then I'll times the 4 by 5 to make 20. And I need an x, and I've got an x. So that's done. 24 c squared minus 6cd. 6 is the biggest number that divides both. It actually divides both those numbers. I need c squared. Oh no, hang on, we haven't finished our factors yet. So that's the highest common factor of the numbers. Then look at the letters. This one's got c squared. This has just got like c to the power of 1. Ah, now someone's delivering something, so the dog is going mad there as well. Oh dear. Right, 24 c squared and c to the power of 1. They've both got at least one c. Hang on, just need to shout at the dog. Oh, it's really quite a day today. Will not work at all. Okay, next. So 24c squared. I've got 6c because they both share the c. Done. They don't share anything else. Now 6 times by 4 would make the 24. And c squared, I've got one c, I need another c to make 4c there, because c times c is c squared. Now I need minus 6. Well, I've already got the 6. Now, I've already got 6c, but I haven't got a d there. So I am going to need to put a d in. Now, if that d wasn't there, I'd need a 1, wouldn't I? So that my 6c didn't just disappear when I expanded. But as it is, there's a missing d, so I put the d there. And then 6c times that would make 6cd. Cool, 2 more. Cool, take a long time these, don't they? Next, 18 and 24. Biggest number that divides both is 6. Again, nothing bigger than that. Oh no, it's not. Silly me. Yes, it is. I was going to say it was 8, but no. 8 doesn't divide those. That would be really silly. Okay, sorry. All right, back on track. So 6, this one's got x squared. This has got x, so they share an x. There's no y's here or z's or anything, so we open up the bracket. Right, I've got 6x. I need 18x squared. So I times the 6 by 3 to get 18. And I then need another x because we need x squared. There's one, there's the other. Now 6 times 4 makes 24. I need an x, and I've got an x. I need a y, so let's put one in. And I need a z. So we'll put that in as well. So 6x brackets 3x plus 4yz. And last one of these tricky ones. 9 and 12. The highest common factor is 3. There's an x squared and an x. So they both share at least one x. There's a y and a y squared, so they've both got a y. Then open up the bracket and see what else we've got. Now 9x squared y. I've got a 3, so I times it by another 3 to make 9. I need x squared, and I've only got 1 so far, so I put another 1 in. I need a y, and I've already got the y. Good. So move on to the next term. 12. Well, starting with 3, I will times that by 4 to make 12. I need an x, and I've got an x. I need a y squared, and I've got one y, but I need another one to make y squared. There we go. Whoa, they take a while, don't they? Next bit then. Okay, so this might be a little bit easier potentially. Just going to shout at the dog again. Yeah, this time we've got blanks. So what was the original expression? If it's factorized to make 4f minus 4, what would need to go in the blanks here? So for example, if I've got this one here, I've got a bracket here. Well, if there's 8 outside and 2e there, this would need to be 16e. And if this is a 3 and I've taken a factor of 8 out, well, that would be 24. You can just kind of expand it really to figure out what bit must be the missing part at the front. Okay, right, so there's 4 for you to just fill in the missing bits of the, there's little blanks here where you need to fill stuff in. Unpause when you're done. Okay, right, if I expanded this, 4f, what is what I would have, so I need to have the f there to make 4f. 4 times the minus 4 would make minus 16. Okay, this is again the opposite. Expanding and factorizing are opposites of each other. Right, 8 times x would make 8x. 8 times the 3 would be 24. Okay, 3p times by that q. Well, that would be 3p q. You just write them next to each other because in algebra, touching means times. Things are touching means times. And then 3p times the 6. Well, 3 times 6 is 18, and it's 18p. They've already put the p there for you. Right, 3m times 3n would make 9, because that's 3 times 3. m, n. Minus, okay, 3m times minus 1. Well, that would be minus 3m. Okay, probably a bit of a relaxing interlude, that one, hopefully. Should be pretty straightforward. Next, when do I use single brackets? And when do I use double brackets? Okay, so all the ones we've done today have had one single bracket, but remember from before, from doing quadratic equations, that we need double brackets for those. So which ones of these are going to need a single and double bracket? So for each question, I'll just do 2 examples. I want you to write single or double. Now this one, you would write single, right? Because I can put this into a single bracket. In fact, it would be 3, there'd be a 3y on the outside, and then 2 minus 9y on the inside. Yep. And this one would be a double, because this is a quadratic equation, just like the ones you were doing last time. Something squared plus or minus something of that. So a squared plus something a plus or minus another number, means it's going to go into double brackets. Now this one would actually factorize into, I think it's going to be a plus 1 and a plus 3, actually. Okay, if I did it. Now, I'm not expecting you to do these bits, all right? I'm not expecting you to factorize yet. I just want you to say, is this like a single bracket like we've done today? Or is it going to be a double bracket? And the double ones are characteristic of like a letter squared plus or minus a certain amount of another letter, plus or minus another number on the end. Okay, those are the sort of double brackets ones. That would be single, that would be double. Right, yeah, fine. Okay, here you are. I just want you for now just to write single or double next to each one. What's it going to be, a single bracket or a double bracket for each one? Off you go. Okay, first one. It's not characteristic of a quadratic, is it? There's nothing squared at all, so that's definitely going to be a single. B, there's a p squared and the p, but there's no number on the end, so actually this is just going to go into a single bracket. Okay, this one, x squared plus 10x plus 25, that's quadratic. So it's going to be double brackets. D was a bit sneaky, this one. This is a DOTS. This is dots. Difference of two squares. Difference of two squares has to go into double brackets. Okay, if you can't remember dots, look them up. Difference of two squares. E, this is typical quadratic, isn't it? Something squared, plus or minus some more of that letter, and then a number. And that would be a double bracket. F, I know there's an x squared here, but actually there's a dead giveaway because there's more than one letter. And that's invariably going to mean that it's not a quadratic equation like we're used to. This is going to be a single bracket. Again, mix of letters here. It's going to be a single bracket, even though it's a really big expression. And the last one, double, even though it's a different letter to normal B. Usually quadratics, for some reason, we always write them with X, but it doesn't matter what the letter is, it's still quadratic. Okay, I bet you can guess what's coming next. And I want you to factorize them, please. Okay, don't forget this one down here is a difference of two squares. Yeah, off you go. Factorize each one fully. Unpause when you have done, and I will race through the answers quickly. Okay, here we go then. So 9 is the common factor. So we have x minus 3 on the inside of the bracket. Right, this one, p is the common factor here. We have 8 plus p on the inside of the bracket. This is going to be a quadratic. So you needed to find those factor pairs. So a pair of numbers that multiplies together to make 25, but adds together to make 10. Well, that pair of numbers is 5 times 5. They're both positive. So you put it in an expression like that. Brackets x plus 5, and the second set of brackets is also x plus 5. Difference of two squares. X squared is a squared number. 16 is a square number, and it's minus. You've got to spot these ones. You do the square root of 16 and find out what that is, which is 4. And you put the letter plus that number. You put the letter minus that number. Okay, next one, the quadratic. It's going to be, if you find the factor pairs of minus 10, you will find that the two numbers you need that multiply together to make minus 10, but add together to make plus 3, would be minus 5. Sorry, positive 5 and minus 2, okay, and you put then the x in front of those. So x plus 5 and x minus 2 in double brackets. Okay, highest common factor is 3. They share an x, so it would need to be 2. I've already got the x, so I need a y. And then 3x squared. Well, I've got 3x. I need to times it by another x to make the x squared. Single bracket, although this is a really big expression, actually, it's going to be a single bracket. Now, they share a 4 is the highest number that divides all of them. They've all got a q. Two of them have got a p, but one of them doesn't. This one doesn't have a p, but they've all got at least one q. So we put a q on the outside. Then I'd need to times it by 2, p squared. Now I need q cubed. Q cubed, easy for you to say. I've got 1, so I need another 2, so q squared. Okay. Now I need 12, so I times it by 3. I've got q, but I need q squared, so I need another one to make the two of them. Then I need 4. I've already got 4. I've already got a q. I just need that missing p. Yep. And last one, if you find factor pairs that make 8, but add together to make 6, well, that would be 2 times 4. So b plus 4, b plus 2. You could have put those brackets the other way round. Okay, I'm not going to go into those too much because we did lots of quadratic ones last time. Dots is the one that really we need to keep spotting because it will come up at some point. Otherwise, it is now off to Dr. Frost with you for some questions to really put this into practice, okay? You know, if you're really struggling, let me know. Don't just suffer in silence. Let me know and I shall help you out, okay? It's called linear factorising, as it says there. You know, just I put pause there, but actually you just need to finish that and be done. Okay, and I shall keep an eye on how you're doing. All right, well done. See you later.